So we have seen little bit of program snippet, how programs are written, but we have to understand a very important concept today in this hour, which is variables. Now, I'm assuming that you all are working on programming languages, and hence you know what is C programming and what is the concept of variables. So as we all know, a variable is a memory allocated for storage for some specific data, and a name is associated with the variable to be used to work around this reserved block. So if we understand in the simple concept that a variable is a value holder which can have different variables at different points, different values at different points of time, and that is why we call it a variable. That because the value is changing, and hence we call it a variable. So variable is basically a value holder which is holding different values. For example, it is holding 10, then it holds 20, and then 30. So it is very much like a value holder. Now, where is that value holder? That value holder is on the memory. So a memory location is a reserved block, and that location is associated with a name, and that name is used in R to store different values. So that is the concept of a variable. Now, in R, how it differs? R language, variables are not declared with a data type first. Like in C, we declare a variable with a data type. For example, int a, b, c, or char a, b, c. But in R, we do not declare such kind of variables. Rather, they take the data type of the R object which is assigned to them. So mainly, if I'm assigning it to an R object, so whatever is the data type of the R object, automatically the variable takes that data type, which means that I'm relieved of the extra task of declaring a variable. The moment I write C equals to something or C equals to matrix, automatically the object is assigned to the variable, and that is the data type. This feature is also popular amongst Python and PHP. So this is one advantage of R over other languages, that we are not declaring first with the data type. Rather, we take a variable and assign it to one R object. Declaring and initializing variables in R. R supports three ways of variable assignments. First is using equal operator. Second is leftward operator, and the third one is rightward operator. So data is copied from right to left. So if it is equal operator, data is copied from right to the left. If it is a leftward operator, data is copied from the right to the left. And if it is rightward operator, data is copied from the left to the right. So you can see the three examples over here using equal to operator. So if I'm saying equal to operator, variable name is equal to value. So variable name is equal to value. If it is leftward operator, I'm saying variable name is equal to value with the leftward operator. And if it is the rightward operator, I'm saying value is stored into the variable name. So that is how I can write. Either all the three are same. Three different ways are there, again depending on the country to country where we are working and writing a code. In some countries, equal to sign is popular, like in India. In certain countries like USA, less than symbol and minus sign is popular as assignment operator. And in some countries, we write value first and then the variable name. So it totally depends on in which country you are working from. Now, let's have a look of how creating a variable in R. We have seen a lot of codes, but this particular code snippet is only focused on how to store a value into a variable. You can see here, I'm writing hello into a variable 1 and I'm printing var1. So what I'm doing, I'm printing hello. So I have stored variable 1 equals to hello with the equal to operator, and I'm printing var1. So var1 is my variable and it is printing hello on the screen. Likewise, I'm using leftward operator. var2 is my variable and I'm storing hello. So hello is what? Hello is my context, which is the constant, and I'm storing this a character constant and I'm storing it in the variable 2, and I'm printing variable 2 on the screen. which is again hello. And in the third option, I'm using hello and assigning it to var2 and var3, and then I'm printing var3 on the screen, and var3 is what? Variable 3. Again it is printing hello. So the output is same in all the three options. In all the three ways of creating a variable, the value is hello and the variable is capturing the value. The only way is how I can write 3 equal to operator. Now let's have a look on the nomenclature of our variables. You must be wondering that there should be certain rules that how I can name the variables. Is a blank space included? Is an underscore allowed or not allowed? So all these questions will be answered in short due course of time. The first pointer says that a valid variable name consists of the combination of alphabet, which is from A to Z, numbers, which are from 0 to 9, dot, which is a period, and underscore, which is not a minus sign but a symbol below the minus sign. So I repeat, there are 4 things which are allowed to make a variable: alphabet, numbers, dot, and underscore. Now let's take one example, var1 dot 1 underscore. This is a valid example. Why? It is starting with a variable with a letter, and it has the two dots, the two special symbols. One is dot and the other one is underscore, which are allowed. Now, apart from dot and underscore operators, no other special characters are allowed. This you have to understand, that you cannot use @ dollar hash to create a variable. So here you can see var $1 is invalid. Likewise, var #hash1 is also invalid because dollar and hash symbol are not allowed in a variable name. Third point says that variables can start with alphabets or dot characters, which means the variables can start either with alphabet and a dot character. For example, .var is valid, or var is also a valid. So I can start with dot or I can start with v. That is valid. Fourth point says that the variable should not start with a number or an underscore. So mainly if I am writing example 2 var, it is invalid because the variable name is starting with 2, which is a numeric value. Likewise, underscore var, this is also invalid because a variable name cannot start with an underscore. Why? You must be asking why it is so. Because there are certain functions and libraries which are having already this nomenclature. So if I create my variable with that, then there will be a clash. So for that reason, only 2 symbols are allowed, which is dot and a alphabet. Dot and alphabet are allowed to start a variable name with. That's all. No numeric and no underscore should be the first character of your variable name. So that is about how to with what should we start and with what we should not start writing a variable name. Now, if a variable starts with a dot, the next thing after the dot cannot be a number. Now this is one more rule. You might say that .1 ABC, that is invalid. So mainly in my variable, after the dot, I cannot have a number. That is one more rule. So dot has to be followed by a letter, and then only I can start a particular variable name. Now let's understand some more concepts that which are called as methods for variables. So R provides some useful methods to perform operations on variables. There are certain methods which can perform certain operations, and these methods are used to determine the data types of the variables. Finding a variable, deleting a variable. So one thing is that I've created a variable, but suppose I want to find out what is its data type. Is that variable name existing, or I want to delete certain variables because they are using memory and they are creating a confusion or chaos while writing a program. So such methods or such small functions are available. So the first function is class function. This is a very common function and it will be used again and again in your coding or while cross-checking. So this inbuilt function is used to determine the data type of variable provided to it. So basically class, and within the class I write variable. Now the syntax is class and within the class variable. In the example you see that there is a variable var1. var1 is equal to hello. So var1 is equal to hello, and I write print class and within brackets var1. So what I'm doing, I have passed hello and the class of hello is returned, which is printed on the screen as an output, and the output all you can see is character. So mainly the idea is the class function is returning the class of the variable. What is the class of the variable, or you can say what is the data type of the variable? So hello is having a data type character. So if I write print class of hello, it is printing character data type. Next we have the ls function. Now, this is also a built-in function and it is used to know all the present variables in the workspace. It is very much like listing, and that is why it is shortened as ls. And this is generally helpful when dealing with large number of variables at once and helps prevents overwriting any of them. So mainly ls is a function which is a list function. Example is using equal to operator. If I write var1 equals to hello, if it is leftward operator, var2 equals to hello. If it is rightward operator, hello equals to var2 and var3. And I write print ls. Now what I'm doing over here, I'm writing print ls means print the list of all the variables which are there in the workspace. So you can see the output over here, var1, var2 and var3. So there are three variables which are there in the workspace, and I'm working on three variables. So the moment I write ls, I'm just printing the list of variables on which I'm working.